Hi, it's Miss Elizabeth, and it is our final session of the Rock Island Public Library Virtual Math Club from this summer. 2020, I thought was going to be a year of perfect vision, but it has turned out to be a very strange one. But I'm glad to see all of you guys at home, and I can't wait to see you back here at the library next summer. All right. Today's lesson is going to be Platonic solids. That's usually our favorite one. If you've been in math club before, usually we use toothpicks, or you could use coffee stirrers. I don't know if you can see that. That's a coffee stirrer. If you have toothpicks at home or pretzels, people use a lot of different things. You just need something that's kind of stick-like. If you got Tinker Toys, good for you. The other thing is that I use is spice drops. So I used to go to the dollar store. These cost me $1. So I get these little spice drops, they're gum drops. The other thing you can use is mini marshmallows. And here's the thing, you're at home, man. If you like cheese cubes or, frozen peas, I don't know, more power to you. You choose what you like, whatever it works for you. And get your supplies together for this activity. The sheet that you have is called Platonic solids. That's named after the mathematician and philosopher Plato. And this is a great lesson. Moms and dads, this is a great one to do some Googling, because you can definitely learn a lot of vocabulary and tie it all together. Plus, it's really fun because we're just constructing. Before we get started with that, though, I'm going to give you today's puzzler. I'm doing it at the beginning because you're not going to be able to come back next week to see the answer. So I'm going to give you the answer at the end. So we're going to start with the puzzler first. All right. So the first thing I'm going to do is I'm going to construct, well, it looks like a football post. And I don't play football, but I'm pretty sure I know what a football goal post looks like. I think it looks like that, right? So it's sort of this Y-looking shape. And your job is to move 2 sticks and make it go the other direction. Move only 2 sticks and make it go the other direction. Okay, so that's your job, is to flip this around by only moving 2 sticks. All right, that's puzzler number 1. This week's puzzler involves, the second one for this week, involves you taking toothpicks or crayons or pencils or whatever you have that you can make this grid. So I don't know if you can tell that these are individual little sticks, okay? So it is a 3x3 grid. So you should know what this looks like. This looks like when we made our square crackers, right? Where we had 1, 2, 3, 4, 5, 6, 7, 8, 9, or we could count by 3s, 3, 6, 9, or we could count by 3s this way, 3, 6, 9. Either way, we have 9 squares. Your job now is to remove 4 sticks and leave 5 equal squares. Okay? So once again, build this, remove 4 sticks, and leave 5 equal squares, meaning they're the same size, same area, same shape. Okay? Got it? That's the puzzler. The answer will be at the end of this week's video. So now we're going to be doing the Platonic solids. So we started off with the puzzler this time so that you could have the answer at the end of this video. So if you've been in my math club before, this is often the time we have a really great time, because basically we just get as many spice drops and marshmallows and a bunch of toothpicks, and we make these shapes. But I also want to know, this is math, don't forget, so we want to talk about some of the language. So the first thing I'm going to point out to you is that whatever you use, whether it's a spice drop or gum drop or a marshmallow or a frozen pea or even a piece of clay, this is going to be your vertex. Vertex. If you have 2, those would be called vertices. So those are like the pointy parts, and you'll see when I connect them. My toothpick, or in this case my coffee stirrers, are going to be my edges. So the first shape I'm going to make is a tetrahedron. A tetrahedron has 4 sides that are the same. So tetra means 4. So if you played the game Tetris, you know that that means 4. And hedron means face. So the face is actually the shape that we're going to be making, and in this case it's going to be triangles. And they're going to be equilateral triangles. So for those of you who are wanting to get some good math language, we're going to make a line segment by taking a gumdrop and sticking, in my case, a coffee stirrer on one end, stopping it up with another gumdrop on the other side so it looks like a line segment. Then I'm going to take my other coffee stir and poke it into the top. And then I'm going to poke this one into the top. And then I'm going to stick them both into one gumdrop. So one gumdrop gets 2 sticks in it. Hopefully you can see that at home. Okay? So that looks like that. So what I'm going to do now is I don't build more triangles. I use this as my base. So this base will be my bottom, and I'm going to put a coffee stir in each one of my gumdrops, poking up. And then here is the really fun part. And what I'm going to do is I'm going to go find a red one because I want all mine to be the same. So you get to do whatever you want at home. So there's one gumdrop, and I got to put all 3 sticks in one gumdrop at the top. So what I'm making is a tetrahedron. So you might think, oh, that looks like a pyramid, Miss Elizabeth. Well, it's sort of a pyramid. It's a triangular-based pyramid, which is called a tetrahedron. All of the faces, so there's one here, one in the back, and then this one down here. So they're open air faces. If we made this with paper, you would be able to touch the face. In this case, you can't. Your finger goes right through it. So we have 1, 2, 3, 4. That's what makes it a tetrahedron. And it doesn't matter how I put this because it's the same. We have 4 equilateral triangles, and that's a tetrahedron. That's our first Platonic solid. All right, now we're going to go to our... Okay. All right, so we're back, and I have my setup already. So the next one we're going to make is a cube. And most of you know what a cube is, hopefully. It's when you have a dice, or die. Actually, singular is a die, but lots of people just call them dice. That's a cube, cheese cube. Sometimes your tissue box looks like a cube. So what I need is I need to have 4 to start my base. So we're going to make a square. All right, so here we go. The first thing I do is I take 4, whether you have toothpicks, pretzels, coffee stirrers, whatever you have at home, even well, some of you have, I say Tinker Toys. I don't know if people have Tinker Toys. Some of you have things like Connects, or even you have those cool magnet things. All right, now I've made my square base, and you'll notice I kind of have another base ready to go, but I'm not going to make it because I'm going to show you that I'm going to take these other coffee stirrers, and these, remember, are my edges. So this is my first face. I made a square, and I'm going to put these in the top like that. All right, so basically I have my base, and you can see that I made it look like a poster bed. All right, now I'm going to stick these on the top. And I decided to do alternating colors this time. And now I come back and I stick these in and make another square at the top. And when you're all done, you need to tell me, how many faces do I get? So let's see if you can count them. I have 1 face on the bottom. I have 1 face on the top. Remember, we could put our hands through these faces because they don't have paper or anything. And then, because we have a square, we have 1, 2, 3, 4. So 2 plus 4 equals? You got it, 6. All right, so we got 6. We made a cube. And you'll notice that cubes are really floppy. So in architecture, we know that a square is not a stable shape. We would want to put a brace right here. But you'll notice that our stirrer will not go here because the diagonal of any square is always going to be longer than its side. So for you advanced students, we would call that the hypotenuse, and the hypotenuse is always bigger than the 2 legs. So we get this nice 90-degree angle here, and this will not actually equal that. But maybe if you're making this with spaghetti sticks or something, you could dry spaghetti, you could maybe try to figure out how to reinforce that and make it more stable. So that's what you can do. Have fun at home and play around with that. All right, we have one more shape to make, so stick around. All right. right, the next shape we're gonna make, and actually it's the final shape that we're gonna make because it's not really very easy to make the final two shapes. The dodecahedron and the icosahedron have so many faces that they are not easy to make with gumdrops and matchsticks and or toothpicks. If you can do it, that'd be great. Let me know. Put it down. I mean, send me an email or something. Tell the library, because that would be a news flash for me. All right, here's how we're going to make the octahedron. Octa means what? So if you think about oct means what number? Do you know at home? Think about an animal that has a lot of legs. Octopus. How many legs does an octopus have? 8. You got it. So octahedron is going to have 8 faces. So what we're going to do is we're going to put this together, and we're going to get a square. So the funny thing about this is the square is not the shape of the face. So when you see the face shape on octahedron, do not write square, because that actually is not the face. What we're actually doing here is just setting it up in the middle, okay? The shape of the face is going to be a triangle, an equilateral triangle. So in this case, once again, equilateral means all the sides are the same because we're using all the same size coffee stirrers. And what I do is just like I did with the cube, I kind of make that four corner, 4-poster bed, but this time I'm going to bring them all to the middle. So this is a little tricky. This one's a little tricky. So if you need a little extra help, this is the one I usually go around and have to help people with. So hopefully at home you're figuring it out. Look what I actually made. I made a pyramid, just like the pyramids at Giza. It has a square base and it has 4 faces on the side. So these faces are actually equilateral triangles, and the base at the bottom is a square. And what we're going to do, and this is going to be a little tricky, is I'm going to put it on its side, and I'm going to add 4 more coffee stirrers, 1 in each gumdrop. So we do that again, and what we're going to do is meet them again in 1 gumdrop and make another pokey little pyramid at the other side. Oh, almost I can see that my guy fell out. Ta-da! It's an octahedron. Check that out. So what I did was I made my square center and then formed my 4 equilateral triangles on one end and attached 1 gumdrop, 1 vertex, and then turned around and did the same thing on the other side. So 4 plus 4 makes 8. So the shape of our face actually is an equilateral triangle. So we have 8 faces of equilateral triangles, and the gumdrops would be the number of vertices, so you can write that in, and the number of toothpicks or straws or spaghettis or whatever it is that you used will be your number of edges. All right, so that's the final shape we're going to make. I'll give you a hint that a dodecahedron, the face shape is a pentagon. That's tricky, 5 sides. And then the number of faces in a dodecahedron is going to be 12. Do means 2, like dos, and deca means 10, like the word decade is 10 years. So when you have 2 plus 10, you get 12. So dodecahedron is a funny way of saying like a dozen. So dozen, dozen, and dodeca both mean 12. And hedron, once again, means face. And then icosahedron, go figure, that means 20. I have no idea why. It'd be something I'd have to go look up on etymology online. So anyway, hopefully you've learned a little bit of something, and you've learned a little bit of some Greek words there, because Plato, figure out who he is. This is a great one to just find out more. And I think Platonic solids are fascinating to me because there are only 5 Platonic solids in the entire universe. And we could build 3 of them. So we have our tetrahedron, our cube, and our octahedron. So I've had a great time being with you at Math Club. It's a little weird because you're not actually here with me, giving me high fives and having a great time. I miss all of you. I can't wait to see you next year. And don't forget to stay tuned for the answer to the puzzler for this week. All right, everybody. It's Miss Elizabeth in the Rock Island Public Library Virtual Math Club. I hope you've enjoyed what we've done. Take care, and we can't wait to see you back here in the library. Remember, you can still check out math material and read some great books. And the math book I recommend for this one is Mummy Math. It is one of those, An Adventure in Geometry. This is by Cindy Nushwander, the same woman who wrote all of those fantastic books about diameter and circumference and all of those. So this is the book I recommend to go along with Mummy Math. We didn't have time to read it, but that's okay. You can check it out at your local library. Take good care. So this football goalpost puzzler, I asked you to move 2 sticks and have it go the other direction. So that one looks kind of tricky to me because I want this to be facing me instead of facing you. So this one, I don't know if you got it, but I'm going to remove this and put it here. And move this and put it here. And now it's facing, the Y part, the stem is facing me, and the open part is facing you. So see how tricky that was? I just took this one and went from here. Now it's backwards, right? The open part's facing me, and the pointer part's facing you. So we take that one. That's a really fun puzzler. It only takes 4 sticks. So whether you have toothpicks or whether you have pretzels or whatever have you, this is a really fun one to ask someone how to do. All right, I hope you've been enjoying these puzzlers. You ready for the answer to this puzzler? So this puzzler had you take, whether you used crayons, coffee stirrers, matchsticks, toothpicks, pretzels, whatever you have, Tinker Toys, and build this 3x3 square. And your job is to remove 4 of the sticks and be left with 5 equal squares. So I'm going to look at this and I can see that I want to leave the square exactly the way it already is because those are squares. So I'm going to take this one away, and this one away, and this one away, and that one away. 4 sticks gone, 5 equal squares left. That's a cool puzzler. All right, you can try this one out on your grandma and grandpa, or maybe an older sibling, or maybe even mom and dad if they weren't watching this YouTube video with you. Okay, that's the end of that one.